10 in the morning and leave at 1 in the night?
Sometimes.
Yeah. Yeah. Yes, I get it. Hey, you and I, we don't have a life, so. Yeah. But look on the positive side. Yes. Can see light at the end of the tunnel, like probably what, 7 more months? 7 more months and you guys will graduate. Your count? Oh, you got to get an app. Okay. But you don't want to look at the number of minutes for 7 more months. That is going to be scary. That's good. Okay. So, did everybody get onto Slack? Did you get onto Slack? Arif? On the Slack? Okay. So there was a suggestion in our mid-semester feedback, Frank, to see if we could initiate the calls a few minutes before 11 a.m. So
Yeah.
would you be okay to set it up like 5-10 minutes ahead of time and maybe just set up the call and maybe we can put it on mute as necessary, but
Yeah. Oh yeah, just to have it up and running. Yeah, absolutely, it makes sense. Yeah.
okay, we'll do that then. And you guys meet like you have been meeting for the past hour, right?
Yeah, we've been here 1/4 past the hour, so our classes run from 1/4 past the hour to the 1/4 past the hour the next hour. So we're in here from 3:15, so 45 minutes. Yeah.
So, and you guys meet like for 5 contact hours per week, if I'm not mistaken?
4.
4, okay. 4 is pretty good.
Yep. So 2 hours. 2 hours on Tuesday, 2 hours on Thursday.
Okay.
3:15 to 5:15.
4 past 3 and 4 past 5. Okay. And I thought like the building, doesn't the buildings close at like 4:30 or 4:45 or so?
No, they will. Not during term time because there is a lot of night courses going on here. They will They will remain open, but they will kind of close down some of the services, so doors kind of get locked and things like that. So access is a little bit more difficult, but they're still open nonetheless. So yeah.
At what time do they come? The security comes and kicks you all out.
I think it's at 8:00. I think. I don't know.
So
something like that.
So if you're in the building past 8, security comes in and kicks. But yeah, you got to go home and work at home.
Yeah.
Or if you're staying past 8, maybe we don't know how to manage our time.
You can always hide, you know.
Yeah,
it depends on the building. So some buildings will stay open quite late, and then some buildings will close. So, for instance, the library will close very much strictly on a particular time. When it closes, and security will come around. And if you're in the middle of a meeting, it doesn't matter. You're gone. Yeah.
Okay. So you guys have like a secret rooms that the security doesn't know where you can hide?
Yeah, something like that. Or
right?
Main buildings, we can kind of, some of us can get into it. Okay, so we have keys. So.
Good. It's 11 o'clock, so most of us are here, exception of 1 or 2. So shall we get started on this?
Okay.
So who is still waiting to go here on this side? 1, B, you. Only 2 on my side.
Yeah, I have two on this side as well.
So we want to start from your side?
Yeah, I think it's our turn. So I will get somebody up here. So, guys, who wants to go? We've got 2 people here. Who's next? John? Yeah? Okay. Okay. So we've only got 1 minute. Right.
Who's next from our side? You guys want to go? Okay, come on over. Sit here and I'll sit there.
Oh,
Oh, that's fine. No worries.
so we're going now, right, Kumar?
Yes, you're right.
Yep.
You are.
So I'll hand you over to Jonathan.
Okay. Hey. Hey, finally we get to see a student.
Hey guys, how you doing?
There he is.
My name's John, and a part of our team is Hugo from MCU, and also Mihal, which is on our side over here. Essentially, can you hear me okay?
Loud and clear.
Okay, perfect. Our project is essentially to add a significant feature to an existing real-world infrastructure. So in logistics industry, freight trucking typically consists of hundreds, if not thousands, of individual trailers in different depots and client facilities. And those trailers that, have goods inside of them, or typically could also be empty, get picked up by a significantly less number of trucks. So you always have more trailers than you have trucks to move them. And typically there isn't a system that autonomously tracks those trailer locations. And so our concept essentially is to implement BLE technology by positioning two beacons, one on either end of these 53-foot long trailers. And then in the cabs of the trucks, they already have Wi-Fi, and they're connected through LTE to the internet. And they also run their own sort of software to manage both sort of the routing of those trucks to provide the pickup and drop-offs, and also driver management, so how long the driver's been on shift and all kinds of different features of that nature. So essentially, we'd be utilizing an existing system of that truck in terms of the hardware that's there, and would be picking up these pings from the Bluetooth beacons on trailers as the truck effectively is passing by the trailers in all of these different depots and yards. And the idea is essentially to create a autonomous network understanding of where all of these trailers are located, to not only learn how long they've been stationary for, but also because we now have 3 points of contact, one beacon on either side of the trailer, and then the base station within the truck cab itself. We can triangulate that to understand the angular direction that those trailers are facing, which also becomes very useful in depots where trailers are quite clustered and can be, the hookup point is on one side, and for the truck to pick that trailer up, it has to back up down a long sort of narrow access laneway. And so knowing in advance, it's a small feature, but knowing in advance which direction the trailer is would help the driver to pick it up. Other features we're looking at is creating a visualization or a heat map. Nothing to do with temperature, but just consider that if a trailer has been stationary for a long time, you could consider it cold. So on a map like Google Maps, you could have an icon of some kind that would be blue, versus if it had just arrived and been dropped off and been picked up by the system, it would understand that that was hot or warm. It was more recent. There's other features that I'm not remembering now, but that's kind of the general gist of it. In terms of our tech stack, we're looking at two BLE beacons, and Raspberry Pi would sort of be the fit-in right now for the cab computer. We're looking at running Python on the Pi. In terms of communicating with the beacons, don't really know how that works yet, so that's part of this whole exercise. And then pushing, so this is kind of an important feature. So we would look at edge computing with Python on the Pi, which would process all of the beacon location points and whatever calculations needs to happen in that sense, happen on the Pi. That would be packaged, we're assuming right now, in JSON format, and then pushed up to Firebase every 5 minutes. So right now they have sort of in industries like a standard heartbeat of 5 minutes, the data gets pushed to the cloud, and so we're sort of just tagging on to that time frame. And then in the cloud, yeah, we're just sort of looking at Firebase now because they have some Google Map API. And, well, I don't know too much about it, but one of the partners here does, so that's good. That's the general gist. Does anybody have any questions? Cool.
On this side, questions?
Okay, cool. How about you guys?
Come on, guys. This is the whole point is you learn from each other. Ben, looks like you got a question.
Okay, so I know this trailer, how long they can be, how many miles they can go before you.
Kumar? We can't hear anything, right?
Yeah, I'm listening to him. Probably Ben. Come on. Okay, here you go.
So for commercial trailer use, that was a mic drop. There's a maximum number of miles that these trailers can go before they can no longer be used for commercial use in major commercial industries. I know at least benefits like that. Could you use this system to also track how many miles these specific trailers have gone, kind of automatically? Because I think right now they just kind of log them on a paper system, or just tell logistics, hey, this trailer insert really long just went 300 miles, and that's all they do.
Sorry, could you repeat that first part of the question? I got just the last half.
Can you use this system, or maybe even think about using this system to basically track how far these trailers go, because there is a maximum number of miles that they can travel?
Yeah, absolutely. So, not just in terms of their location data and how long they've been stationary, but imaginably we could create some kind of a filter that you would select a particular trailer ID and then see over time its coordinate positions, on a map. So you would notice how far it had technically traveled between those points. The routes of those, I guess we'd have to tie into the actual routing system that exists, but that sounds harder to do right now. So, great idea. That would certainly be something we could look at doing if we get this done sooner than the end of the semester.
Great.
You got any of that?
I'm just wondering if they're.
Did you say something?
Oh.
Sorry, guys, still nothing.
Can you hear me now?
Yep, perfect. Clear.
Okay, great. So maybe a question and maybe a suggestion here is like iBeacons, the beacons that you're planning to use, and the cab system that you were talking about. Is that going to be in a real implementation or just a mock-up in a lab?
Kind of a hybrid between the two, because I don't think we're going to have access to a real world trailer. But I figured what we could do is get 2 beacons and measure out 53 feet in a parking lot out here, and I guess replicate it over there, and then hold a Raspberry Pi and a laptop or whatever, and literally just walk by them at varying distances to sort of simulate what would happen in the real world.
Okay. So why beacons? Why not an active RFID tags or some tags?
Good question. So beacons were essentially just suggested by one of these companies, and so sort of just started running with that. But knowing a little bit about RFID, I understand that to pick up an RFID tag, you require an interrogator. And that would be essentially an additional piece of hardware that would be required on board these cabs. Mm-hmm. So it's certainly an option. And I think when we get into the brass tacks of Bluetooth, we'll also have to do the same thing with RFID, because obviously a lot of these containers coming off of ships have RFID in them as well.
Yeah.
So it is an option. To be straight up, I don't know if it's better or not right now, but it seems like potentially more expensive option if it requires interrogators. But maybe that would be balanced out by the stickers being cheaper than the beacons. So
yes, I mean, you hit a good point there. I mean, beacons are good because have a Bluetooth transceiver probably on the Pi, right? I mean, that is a good thing. That is a low cost. But
Yeah.
when you go onto the cabs, they have a good amount of battery power and they have a good amount of space. So in a way, in real world, probably, at least my thought is space and power is not a constraint on the cabs, right? Yes, associated with probably the reader. Yes, there is, but as you said, like if already the trailers are already tagged with RFID tags, it might be a little easier. But again, there is challenges with it. I'm not telling you to go to RFID. I'm just saying we got to study both and make a logical decision. Is all I'm saying. Okay.
Absolutely.
And with RFID, you got to be careful on that because the only signal it gives out is the RSSI. Okay. Received signal strength indicator is all it gives. One signal. Okay. And it gives you a value which is not linear to distance and which is very strange. I mean, sometimes, like, let's say you get a signal at 10 feet and you might get the same signal at 100 feet. It is very unreliable. So that is something also keep in mind that as you travel, your signals might be, the RSSI fluctuates significantly. Okay.
Okay.
That in mind. Yeah, but it's a good project.
Cool. Thank you.
Any other questions, guys?
I have one question before.
Oh yeah, sure.
Unless they don't have any more.
I feel like we're on a talk show now with this thing.
Hey,
Good interview.
we're not late night comedy here, so.
Oh,
Yes. So, okay. This is it. Apparently, we don't have any more questions here.
Okay, I just have one question here. BLE beacons. So how long are these? How long are the trailers? How long are the
The trailers are 53 feet.
53 feet?
Yeah.
And have you looked into it in any of the lit there in terms of the range of BLE beacons? Is it
Yeah,
is it
so
ample?
I found some examples of BLE beacons that were somewhat affordable, that had battery power lasting up to 48 months, so 4 years, which is enough time to make it worth rolling out to thousands of these things.
Yeah.
And the ranges of those were, I think, 4 dBm, which is like 20 to 30 meters,
That's all right.
which is
Yeah.
far enough.
Yeah.
And I think there's probably ways of playing with those numbers, so
Sure.
lasts a little less but goes a little further. But to be honest, all that dBm stuff, I'm still trying to figure out. It's new.
Okay. And is that what, and in terms of distance calculation using beacons, have you had a chance yet to?
Yeah, one of the papers we came across described how to clean a single signal or filter it, and then how to make the calculation.
Right.
And just looking now, actually, we found some Python code that we would understand,
Okay.
but we could use as reference. It's only 40 lines, so whether it
That's
works or
all
not is it to be seen, but it seems like something that's quite achievable. Triangulation thing is probably around the same, but I don't know about that yet.
Yeah, that was my next question. Triangulation is
Yeah. Well, I
interesting.
know it's doable because
Yeah.
it's being done, but beyond that, I don't know.
Yeah, I just from my own point of view, the accuracy is something I'd be interested in, but I guess you'll find out.
Well, the good news is that we always know how far the two beacons are apart.
Yes,
so that
so that's your
probably
reference, yeah.
is a nice
Yeah,
So-
you know that.
that fixed.
Hey, it sounds like a real talk show now.
All right, thank you. I'm finished. Any questions from any of you guys here?
I have a small addition to add on your conversation. We do have research here done on exactly what you're talking about already.
Perfect. Project finished.
We have done that in our lab here about 2 years ago.
Okay.
Maybe 2 or a little over 2 years ago. We did localization of beacons. Primarily, we did indoors. We did not do outdoors, though. And we are able to tie the RSSI with the distance and also triangulation.
Nice.
And with triangulation, the highest accuracy we got was about 3 meters.
It's pretty good.
3 meters, but remember, like we deployed not just one beacon to get triangulation. We had to deploy beacons like in a square pattern, rectangle patterns, different patterns of deployment. So the average probably I would say is about 5 to 6 meters.
Okay. Well, given the length of the trailer, that at least, yeah.
So just keep that in mind. I mean, if you can shoot me an email as a reminder, I'll send you the paper that we wrote, and it should have some of that information.
Yeah, that'd be great. Thank you. I will.
Yes, sir.
All right. Thanks very much,
Yeah.
guys.
Oh, you're up next. Okay. There we go.
Hello.
Should I use my team?
Yes, please.
Okay. Our team, we have team number me, 10, and
Who are you?
okay. I'm Jin Wenjiang, and I have team Jianing Tan and Emmanuel. How to read that? Am I right? Emmanuel
City Chol.
City Chol.
Probably, yeah. Emmanuel. Just
Yeah.
It's around so they can see you rather than look.
Hey, there we go.
Okay. Our project
Hey,
is.
that's their classroom.
Okay.
Here, I'll try and you keep going there. Sorry, I should have done this earlier.
Our
There you go.
project is an IoT-based smart bus system, which can help build a smart city. That's a hot tendency nowadays. The system allows riders to know the location of bus and the number of empty seats and the estimate waiting time. This helps riders to properly. It means that they can decide when they want to get to the bus stop rather than just waiting there and wait for the bus. This system can also send real-time information to the transportation companies, which helps them to optimize the transportation system, such as the bus schedule, the proper routine, and the price of tickets, etc. The most important of this project is the smart buses. We have embedded sensors connect to a microcontroller like Raspberry Pi, and we send the data to the cloud. The main data collected from the buses are the number of passengers and the location of the bus. Our tentative plan is use GPS to locate the bus. The position can also be seen by the riders. Also, the position is one of the factors that we need. We need to estimate the waiting time. We also use the laser sensor, or we haven't decided that, or maybe the photoelectric sensors to measure the number of passengers on every bus and send the data to cloud. The information will be analyzed on cloud and sent back to the riders so that they can know if there are empty seats and when the next coming bus will get to the bus stop. And the number of passengers combined with the location can also reflect the density of riders in that bus stop. So it helps the control center to arrange the bus schedule, which can optimize the transportation system. This is our temporary plan. We are still discussing some useful functions for these systems, like help people monitor the old people or the young kids. It means when they get on a bus or maybe they missed one, their parents or their families can know. Like that. It's our plan.
Okay.
Any questions or any suggestions?
Any suggestions from here or questions?
Just how were you recording the number of people on a bus? How are they getting on and off?
Okay. Can I'll just repeat the question I got here from one of the students. Again, yeah, what sensor are you going to use to record the number of people getting on and off the bus?
Oh, like I mentioned, the laser sensors or the photoelectric sensors.
Oh, lasers.
Okay.
Might be.
Or maybe we can just, the tickets can help.
Okay, lasers are good, but they're expensive, high power. I mean, one of the things probably you can look into potentially is make it simple, in the sense like maybe you can do simple IR sensors to see how many are blocking it. One way, I mean, maybe a combination of two IR sensors and timing, right? So you can find out if they're getting inside or getting outside, or you could use that. Or one other potential is like almost everybody carries a cell phone with a Bluetooth in it. So if you can capture the number of Bluetooth signatures, unique signatures, that could be one other option. I mean, but if Dr. Walsh or the students have any other suggestions on doing that, I'm all ears. Yes, sir.
Change in
Yes.
that
That's a good point.
music masters would create a change, and that's particular to people. Like you can register that.
Okay.
Particular.
I don't know what to mean.
Okay, yeah, we have a suggestion here for sensing people. Do you want to come up here, Connor, and vocalize that yourself rather than me repeating it?
Just capacitive sensor might be a cheap way of doing it. If you have two plates, capacitance between them, the change of material between them from regular air to air and a person would be readable, and you could have a particular range that you'd know will be a person rather than, say, just something that happened to fall into the sensor. So it's accurate, but it's really low power.
How about building it, though?
Like capacitance, like, so we're talking about building a capacitance in real time. Yeah, I mean, I like the IR. I like the IR better. I mean,
Thank
you
you.
have two IR sensors, like at some combination of the bus. Like if this is on the outside, this is on the inside, right? If this one gets triggered first and then this one, you can getting in. This gets triggered first and this goes here. You can say they're getting out. The number of times that, I mean, but still, only one can go in and out, right? Yeah. Sure. Or
If you could, like, when you scan your bus card or
I like,
buy
yeah,
a ticket,
I was gonna say.
show that the person's on there. Buy a ticket, you your stop.
Yeah.
That person's on there for the stop.
So, or just press a button when you're getting in and out or something, increase your counter, which could be some other simple option.
Thank you.
So, who is Emmanuel there, since we are seeing the students there? Who is Emmanuel and your other student there?
Emmanuel is here. Do you want to come up, Emmanuel? You can show yourself. Here, I'll show you him here. Look, there he is.
Oh, there we go.
Say hello.
We have seen.
And who else is a member of that team from here? Is he? Is it just two?
Okay,
Oh, three, and the other person is over there. Okay.
Who's on your team?
Tan.
Tan. Oh, you. Tan. Okay. Okay. So maybe you want to come up and. Oh, turn this around. So, okay. Tan.
Hey. Oh.
Okay, there we go. Okay, so who else is?
Oh.
Okay, thank you. Nobody else? It's just you? Come on up, guys. Both of you can come on up since you're the last one. So come on. Come on, B, you can do that. Or here, you can grab the chair. It is not recorded, don't worry.
Turn this around so it's a little bit more perspective this time.
How's it going, guys? Can you hear me?
Yeah, can hear you loud and clear.
Okay. I'm Justin Lazat. We good?
No. That nobody's recording.
Frank is recording.
Oh, Frank. Oh, maybe here.
Here, I'll move it back to me, sure. Okay, you work away there.
Alright, so like I said, I'm Justin Lazat.
I'm Beatrice.
And we're working with Lodi. And our idea for the project was a lot of people accidentally leave pets or babies in cars. So we came up with the idea to have a system that will sense if there's a passenger or living being in the car, and if the guardian of said being whatever gets outside of like a certain range, it can alert them on their phone that they have left their baby or pet in the car. And then to go further with that too, if have heat sensors in the car to monitor the car's temperature, and if it reaches unsafe level, it can lower the windows to allow some fresh air through. And then also, in a very extreme case, if there are extreme temperatures or they have been left in there for a long amount of time, that the proper authorities can be notified. We were thinking about how to do this using like heat signature sensors. That way it can detect a human or pet, because they a lot of times they're hotter than the surroundings. But then also if the car was like around 100 degrees, then you'd be able to see they would be cooler than the car as well. So you'd be able to detect them that way. Using the Raspberry Pi for control, and then having Bluetooth capabilities to send the alerts out, as well as using that as possible like range for like to set the proximity, like 10 feet or 5 feet, whatever we decide is a good range to set the alert off for the system, and motors to roll down the windows. That's probably about it. Is there anything you want to say?
No, I think that is basically the project.
Is there any questions then?
Okay, any questions from this side, guys?
Are you going to implement it on a vehicle?
So I'm repeating a question here. Are you going to actually implement this on a vehicle? How are you going to demonstrate it?
Right now, not totally sure. I mean, a way we could demonstrate it without doing that is just kind of having like a defined space, and then having like the cameras detect something in it, and then just having the motors pull down something, not necessarily windows, if we didn't want to implement it in a car. I'm not sure how hard it would be yet to implement in a car. I can imagine it might actually be hard having to get to the windows and stuff, so that might not be feasible. But if it is, then yeah, I think we could try. So.
Okay. Any other questions from you guys?
Scout.
Alert go to like the person's cell phone?
Yeah. So,
Okay. Repeat the question to them. And
oh yeah. So the question here was, does the alert go to the person's cell phone? So obviously, if there's like a baby, it's gonna have a parent. So this would be like an app on your phone, that coincides with the system. Yeah. And so if you leave outside of that range, then you would get sent an alert first. Because obviously we don't want to jump to the extreme of like calling the authorities right away. It's only been like 5 minutes or so or whatever. So you would get an alert. But then that's why we have the heat like sensors in there, because if the car starts reaching a dangerous level to where whatever's inside could possibly be injured or die, then that's when the system would take other actions like rolling down the windows or calling authorities.
So you're saying once they get out of the range for Bluetooth, that's when they get the notification?
We'll like, oh yeah. Thanks, Austin. And then he just asked, once they get out of the range of the Bluetooth, that it would give them the alert. Well, I mean, we would use Bluetooth to send the signal. We haven't exactly figured out like how to set up the range, I guess.
About it, if you go to a grocery store, you're not going to be near Bluetooth capabilities.
Right, right. So, so I'm not. I guess that's a good question. We'll have to look further into that because, but I mean, we do need to set up a range and then somehow get the alert to their phone. And so, yes, it might be using the range with Bluetooth and then sending the signal. Else, we haven't exactly figured that out yet, and that's something we're looking into. So.
Are you distinguishing between sets and babies because the probability for a baby is child protective services, but for pet points, or do you just call it
So the question was, are we distinguishing between pets and babies? Well, our idea was to be able to distinguish between both, not in the sense of like, yes, this is a pet, yes, this is a baby. I mean, obviously, I don't know how you feel, but most people probably would like to see either die. So if it gets to the point where authorities need to be called, most likely, yes, it would just alert the police so they could come and get whatever's out and maybe find the actual owner of that. And then the steps from there could be taken, because in that situation anyways, Child Protective Services wouldn't show up right away. It would be, and they would follow up, so they could follow up after the initial police report is done.
No other questions?
Any other questions over there? Austin?
So if like your end game is to dial 911 in like the worst case scenario, how would you protect against like false alarms? So for them, you dialing 911, if you have a lot of false alarms, it becomes a very serious issue.
So the question was how to protect against false alarms when dialing 911. Well, that's why, like originally, it would not jump to that worst case. It would send an alert to the phone, so that way it would make the guardian aware. And then we were thinking with the temperature sensor to roll down the windows. So that last case scenario, it'll have to go through both of those and then still be at an unsafe, and then also add like amount of time. So if there's unsafe temperatures within the car, and then the windows roll down, it's still reaching unsafe, and it's been like an hour or whatever that the living thing has been left in the car. Obviously, it's probably unsafe for them to continue being, and the guardian who got the alert is just not, they're not coming back to worry about that. So then that's when so hopefully that would help with cutting down on false alarms. They would have to kind of do a couple steps first before it got all the way up to.
So suggestion. So when you're driving, if you park your car and sometimes you get a notification like the car's parked here, you kind of implement something like that.
That's
where
what.
you're tracking when you leave your car.
That's what I was kind of thinking.
So like
that could just go through cellular.
Oh,
it's like the same idea. It's like it knows when you park your car. It's like you're traveling at this speed, you get to the location, and you walk away from your car. So you might be
Okay.
like that kind of thing for your sake. I think that you have to figure out
Right.
And that has like a wider range to it.
Yeah, that's something we should look into. It's a good idea.
Thank you, Joey.
Is that possible after the window went down and the pets or baby or will go out of the car?
That's actually a good question. So the question was, when the window goes down, would it be possible for the baby or pet to leave the car?
The baby can walk
it's
jump out of the window?
See the baby strapped in.
Well, most likely with that, we wouldn't have the windows roll all the way down. Like when a lot of people leave their car, they just kind of crack them, because they don't want people breaking in or whatever. So we'd still have that kind of same issue. So it would just lower them to an amount where
you could let the
air could still flow in. I mean, it's not a foolproof. It's just kind of another, tool to maybe give more time for the parent or guardian or whatever to get back to the car, or to spare moments, because if they're not back there and the car's already at unsafe level, because it's so hot in the car, we're just trying to get minutes, valuable minutes possibly. So.
So, would this system be based off of temperature, obviously? What if it's like cold out though?
That's actually a good question too. So it was asked if it was based, since this is kind of based off temperature, what if it's cold? Unfortunately, there doesn't seem right now realistically how we would warm up the vehicle without the vehicle being on, so that's kind of hard to do. Now that would be something in our system though. Now if it had been like 20 degrees out for like an hour, obviously it's still probably unsafe, and that would be, I guess, one of the parameters that would cause alerting of the authorities. So if it had been that cold, we wouldn't really be able to take that in-between step of trying to help with the coldness, but it would be something still monitored. If it's been unsafely cold for a while in that car and nothing has been done, then
it's something you can look in the time with that. A lot of vehicles nowadays have an auto start. You could tie that function into it, where like you could do an auto start function.
Yeah.
Yeah, that's true. That's a good idea. He suggested a lot of cars have auto start, so maybe work that function in with it.
Yeah, it's a good suggestion. I was just about to say that over here as well. It is possible to have the car wake up and turn some of the systems on, like the heating, if required, or aircon for that matter. It's kind of done in a couple of different, particularly in electric vehicles. It's already been solved. That's where the car maybe would warm up before you get to it in the morning and things like that. We have a question or a suggestion. Is that correct? Yep. If you bear with.
I don't know how many people are leaving babies in cars when they go get coffees and stuff like that. Hopefully not tonight. But I then imagine where it would likely happen more often, which is in garages. So like, mom puts baby or dog into car and then forgets something, before having opened the garage door. The car's running, she goes in the house, and then maybe takes a little longer. So I was thinking the sensor for carbon monoxide might be a good idea. And then using that same feature of turning on the car, you might be able to turn it off automatically.
Yeah, that's actually a really good idea. I didn't think about that at all.
Just a house option.
I can attest to that. It happens more often than you think.
I have to kind of confess, you got a real life case here about leaving a kid in a car when they get home. So your project is kind of a bit open for me. I'm very interested in this because on 2 occasions in my life, a situation like this has occurred. And in fact, in Ireland here, the Road Safety Authority have run 2 campaigns along the lines of what your system would somewhat address. And one is leaving kids in cars, and the other one is another one which might have a bit of a application to what you're doing. If you're instrumenting a car to monitor like a baby in a car, one of the major causes, and it's probably the same in the US, of car crashes over here is people who are driving where they look around and they try to observe they just want to see their kid is okay in the back, but that looking over their shoulder split second can be dangerous. So it's another consideration, but I think your idea is good. And yeah, I've what Jonathan has just kind of said there, and my wife as well, we were guilty of that once, and luckily the child could wake up and get itself out of the car and come in later. But anyway, so yeah, I'd be interested to see how good your system is, because I'd be very interested in implementing it. One other observation I'd like to make. So the idea is that the car, the vehicle itself is a connected car, right? So it's got its own separate connection to the internet in some way, shape, or form, right? Okay, so therefore, and also just to clarify, is the concept as well to be a kind of a contained one too, whereby if I do get out of my vehicle via Bluetooth and Bluetooth only, that the app on my phone will somehow be able to notify me if I do leave behind a kid or an animal in the car. Is the connection to the internet absolutely critical for the systems to work? I suppose is the question. or have you thought about it?
I guess that's a good question. What I guess like to get the alert, does it need to be connected? Is that like what you're asking, or?
Yeah. So, for instance, what I'm trying to get at is part of what you're proposing as well, that via Bluetooth technology, if I get in the car and I bolt in my kid, say for instance, scenario is I bolt in my child into the baby seat, yeah, and I drive along, and then I get out of the car, I forget about the baby, but the app should maybe maybe it's a smart seat, that's Bluetooth enabled, it's hooked up, it's paired with my phone, it knows, yep, there's somebody in me, right?
Right.
You haven't disengaged me yet, like as in you haven't opened the buckle, and then I walk away from the car, and then the Bluetooth goes out of range, but it hasn't registered the fact that the app hasn't registered the fact that I have, that you've taken the child out of the car, so therefore it might spring into life and start ringing alarm bells all over the place. Do you get what I'm, as in this container, it does not need a cloud solution is what I'm talking about.
That would definitely be something that I would have to.
Well, again, it's something to think.
Let's look into it. I don't know if I still totally understand your question, but
It's more of a suggestion. Is that like it's kind of it's a safety application you're doing, right?
Right.
So the idea is that it should work. It should work in a lot of different scenarios. For instance, whether the car is connected to the internet or whether it's not connected to the internet.
Okay, yeah. No, yeah. So yeah, we would want something like that. So yeah, it's something we'll have to look more into. We haven't looked greatly in depth of getting these signals sent, and possibly, I don't know why a kid would be left in a remote location, like you're out in the mountains or whatever, but we would want it to work if, say, it happened.
Yeah, that would be nice, in case I leave my kid in that car and I'm up the mountains, yeah. Okay. Well, very good. Any more questions from over this side, guys? Oh, we're good?
Okay. Thank you, guys.
Thank you.
Thank you, guys. Okay, I'm back. Okay, finally done with the presentation. So, good job, guys. Good job, everyone.
Yeah, well done.
Yeah. So, a couple of things about the project moving forward. Everyone is writing the papers, and so if you can, at least the students here, you can send me the papers, the proposals that you have today. I can mark them up and give you feedback by the time you come back for next class. Okay. That is number one. Number two is I will probably propose with Dr. Frank here that we have tentative timelines and requirements moving forward towards completion. Okay, we have the proposal, but it's soft deadlines. It's not hard deadlines. It is just probably saying, okay, at least on my side, we're going to say, okay, let's come up with maybe the rationale for this project. Let's dig down and see what is the motivation. What is the previous work done? We can just do offline discussions on that. Would you be open to that? Like the way we did like 2 weeks ago we met like group by group and had discussions. Are you open to that?
Yeah.
Okay. We'll continue that. And I'm going to post a Google Sheet probably and share the link with you guys. I would ask that each of you identify and list the supplies you need for this respective project. Okay. I will also specify the list of supplies we currently do have. Okay. And I would recommend that, like for example, if you're looking for an accelerometer, okay, we want to make sure the accelerometer here at CMU is the same one as available at WIT, right? Because your team member is trying there. So Dr. Walsh and I have put together a list this past summer on the supplies that we both are going to have. So share that list with you. Just identify what you need in there. I mean, if we have what you need, great. If we do not have what you need, at least on this side, I'll try to get them for you as soon as possible. Okay. So your homework before you go today is going to be sending the paper, the proposal paper to me probably by end of today, one. Number two, before you come back on Tuesday, update the supplies list on the Google Sheet I'm going to share. Dr. Walsh, are you okay?
Yep, that sounds good to me. I think it'll be good to finish the concepts and the proposals today.
Yes.
With respect to the equipment, the sooner, from my side anyway, the sooner I have a list from you guys of what you need outside of the inventory that we have here, then the quicker I can start moving on getting it, because we're going to have to get it through. The way we work here is that we have preferred suppliers, and we have to work through those suppliers. So the sooner I have it, the sooner I can get on to those guys and see, one, they have exactly what you need, and if they don't, then I have to go and try and source them. And if they're not outside preferred suppliers, that's where it gets a little bit complicated maybe for me, because I have to find 3 other suppliers that provide it. So it gets a bit complicated, but that's it. Once we know early, if we know by next week, it should be fine.
So do you have like a list of suppliers, like for example, Adafruit, SparkFun, and are they in your list of suppliers or no?
They should be, because I got stuff from them last year.
Okay.
So once we've, it's just that they're on the list. So I think really what happens here is that if I go to procurement and they have never dealt with a particular company before, then that's an issue it's not an issue for them, but just the process is different. But if it's something like, SparkFun or RS Electronics, then yep, I'm good.
Okay, we'll try to stick to that on our side as well. I will mention a couple of websites, guys, like SparkFun, Adafruit, Amazon, Mouser, a couple of things like that. I will send you the links and try to see the parts you need only from that. So that way, on WIT as well, they can get it relatively easily.
Mm-hmm.
Okay? So with that, probably we'll end this Skype call, and then I have to follow up with my students on other things that got me into trouble. So.
Okay. I would just like to add one more thing before we wrap up here. I said it to my students here, and I think we talked about it ourselves before. Before you submit any document, it's probably a good idea to either, one, get it, and that's a good thing about working in teams. This is probably happening already. There's more than one set of eyes reading it before you submit it. But two, there's some pretty good tools out there as well to help you with the quality of your document. I'm talking about something like Grammarly or similar.
There you go.
Where you can just pass it through there, and you can get a bit of feedback on the quality. And I do it all the time myself. I kind of have to, because otherwise,
There's something for you guys. Yeah. Oh, come on.
So it would be good for you to do that before you submit any document, and not just for this module, for anything really that you write.
Yeah. Yep. And lastly, are we going to set up Slack groups or?
Yes.
Okay. Perfect.
So I think we know. I think you guys yourselves are. I think one group has already set up a Slack group for. Yeah. Okay. So you can actually do it yourselves.
Oh.
So
okay.
The administrator of the URL doesn't have to do it, so you can do it yourselves. So you can kick off with that straight away.
Can you guys handle that this weekend? It's already done? So 2 of my students say they created groups, so the others will handle that probably today and tomorrow then.
Yeah, and one other suggestion with those groups, I think just for our visibility, can you make sure to include both myself and Dr. Kumar in your group, because we're kind of honorary members of your group, okay?
Yes, honorary members. I don't know what that is, but I like that word.
It's just so we can see interaction and see how things are going, so it'll be nice. And of course we can, as well as that, if we are members of your group, we can observe the interactions and what you're talking about, and we can pitch in as well if we have something that we can add that will help you with your project. Because otherwise we can't see it, so we don't know. So you could be maybe going off on a tangent that mightn't work for you, and maybe it's something that either myself or Dr. Kumar can help you with.
Okay. Thank you much. Okay. We'll talk later then.
All right.
Thanks. Bye.
Bye-bye.